The next thing I would say is that they always stay in their own field. So users usually either stay in CAD field, or when they are simulating, they stay in simulation and don't want to touch the other things. But I would say there needs to be a real change where engineers should have the confidence where they can say, okay, I'm not a professional in simulation, FE simulations, but I understand the basics of it inside this solution space that you have, and you can move automatically the parts around and then try to find optimal positions for the parts in relation to each other. And this way you can also use pathfinding. I mean, search algorithms in general, you have to think about what can I do with this information? The information that you get is always point A to point B in a certain, I would say, criteria. In terms of A star, it's always the shortest path, but you can also use other algorithms. Our colleague who developed most of the AI stuff, where they predict the optimization shape of a geometry based on the loads that you apply. So you train the model and then you just tell where the forces are and how it's fixed, and then it will tell you the optimized shape. And this can actually save a lot of time for anyone who does optimizations.
Ladies and gentlemen, welcome to a new episode to the Connected Engineering Podcast. Today we'll talk about cable routing algorithms, a very, very exciting topic. And today I have a very special guest, a friend and colleague, Rahman. Welcome.
Yeah, thanks for having me, Yusuf. Sometimes the charm, you know.
Definitely. Very exciting. So maybe give the audience a little bit of a background. So today we'll talk about, as I said, cable routing algorithms. And I think your thesis covered this algorithms in a little bit more detail. So what are you actually doing at Synera, and what is your kind of background?
Yeah, of course. I was a customer success engineer. Now I'm solution engineer at Synera. We changed the roles a bit after we restructured. But I'm basically still in customer success as an engineer. So I actually studied automotive engineering. Engineering is my bread and butter. And I mostly did CAD and FE simulation stuff. This is basically where my focus is as an engineer. And at Synera, what I'm doing is basically help the customers use our software to solve their issues. So usually we have weekly meetings or bi-weekly meetings, or I'm just in customer support in general, where they can write me. We have direct contact, and we try to support as much as possible so that we can help them understand the software better and help them become autonomous to use our software to automate, because it's still a new software, even though we try to make it as easy as possible with our learning material. It is a lot of times, in my experience, faster for them to have help from me so that we can look at the specific problem, and then I can show them how to solve that issue.
Yeah,
or the problem.
Yeah, that makes a lot of sense. So you mentioned CAD, so we'll jump to CAD in a couple of minutes, like what the problems is, especially in terms of cable routing algorithms. But yeah, maybe what is some of the algorithms that you maybe want to mention in this podcast? Some of maybe the more well-known, the A-star one algorithm, and like what is it all about, and what is it from a fundamental principle? How does it work?
Yeah, sure. A-star algorithm is basically, it's called search algorithm in computer science, which I did not study, but nevertheless, it's a basic topic, basically, because it's one of the first things that you learn when you tackle algorithms in computer science. And one of the, I would say, basic topic or fields in computer science that deals with the question on how to find a path in general. So you can think of a maze, and how can I go from the start of the maze to the end of the maze? And this is something that the computer scientists ask themselves. And one of the earliest ones is called the Dijkstra algorithm, named after the person who is called Dijkstra. And beside him, there are a lot of different algorithms that have been developed in the meantime. I mean, we can see how computer development in general has progressed. So the algorithms themselves have become much more complex. And but still the basic algorithms, for example, A star is actually really old, but still so good that it's still in use. So yeah, you want to go into the detail of A star first, or should we
I think from a
jump back?
computer science perspective, Rahman, I think this is quite clear, like how it works, like solving a maze, etc. Of course, if we engineers, we don't solve mazes on a day-to-day basis,
Yeah.
but we rather solve like maybe problems in the automotive space. So can you name a couple of examples where the cable routing or like a pathfinding algorithm in general might become important for us engineers?
Yeah, sure. So, in my experience, now that I've finished my thesis on cable path routing, I've seen that many automotive companies and also engineering service providers, they actually do whatever they think is best. So they have developed their own processes, and they decided, okay, we start with this, and then we try to get to a certain point. And I have seen really different mix-ups on how they actually tackle this problem. And I've seen really organized ones where they start really with mapping the electronic parts and then which one needs to be connected to the other one. And based on that, they select electric plugs, and then they later go into the 3D and CAD and try to connect the cables there. And I've also seen like really weird ones where it's completely manual. So you just have the parts. They say these need to be connected, and then you have to find the path yourself. So in the 3D space, you have to place points, and then sometimes they have their own scripted solutions where you just select the points and it automatically creates already the geometry that represents the cable. But it can also be a really tedious task where you have to manually move everything yourself to make it fit, basically.
Yeah, I think Moritz mentioned that in one of the podcasts earlier when we started the podcast, actually, like that engineers still measure manually, like from point to point, and then you still have to see, is there like a heat source? Is there something else that might be in the way? So it's really, really tedious, as you said, Rahman. So what is the advantage now of using something like a Synera node maybe that works on this that optimized cable routing algorithm?
Yeah, sure. So the main advantage, of course, is like everything in our software, we try to automate. So we want to save time and open up the possibility to explore different solutions or different variants. We had one, I don't want to go into specifics, but the company has different variants of the same car. And depending on the variant, maybe it's shorter or longer. Maybe some components are placed differently, like a tank or something. And based on that, your connections, of course, are different. And right now, what they need to do is actually for each variant, they need to put in time to make the cables and the path so that they can see if it works out or not. And also to estimate costs. Cables also cost something. It's not irrelevant in and of itself. And this is, of course, always taking time. And they say they cannot explore all the variants that they want because they don't have enough time. So they actually need to estimate which one is probably the best variant and then just go with that one. So what Synera can do is automate the process, and then you can just run the thing overnight, or depending on how long it calculates, maybe days, but you can calculate all the variants depending on how many variants you have, and it will then show you the cable paths for each variant without you having to always move the points and try to make sure there are no intersections.
Yeah, you kind of summarized a lot of points into kind of 2 sentences. Can you maybe walk us from the beginning to the end? Because I think you also recorded the video, which we'll share under this podcast, so people can have a look at it. So from the beginning to the end, Rahman, how does it work? Maybe setting up something like a cable workflow. Cable workflow, basically.
Yeah, sure. So we have to generally differentiate between the steps that we are doing. So one is this cable path, cable routing section that we are doing, which is the ESTA algorithm that we are using inside Synera, which we can also manipulate. So just keep that in mind. But the very first step that we need to do is we need to have a geometry and a design space. Design space meaning we make the solution space that we have, we discretize the area, because for search algorithms to work, you need to be able to have places where you can go. So you need to have a point grid, for example. In our case, we use the voxels, which are, you can imagine as some small boxes, volume elements, and they have middle points. So you have a point grid, and you can move from each middle point to the next one. And this is how you actually search the path forward. And after you have your geometry and you discretize everything, you subtract all the obstacles from the design space, solution space, so they are not available anymore. So you automatically exclude the obstacles so that you don't have intersections with other geometries. Next step is just to choose the points where you start from and the endpoint where you want to go. And sometimes you also have intermediate points where you say, I don't want the shortest path in this whole space. I want to actually go in a certain direction because sometimes it's necessary to go around and not always to have the shortest path. And in Synera, it will automatically actually generate the path to the goal. And then afterwards, you can do some post-processing because the curve that you get for generating the cable might not be always straight, or it might have sharp corners. So we have post-processing capabilities for curves where you can then smooth out the curve, or you can have some rules to make sure that it's not bending in a sharp corner. And this is how you would actually just automate it. So you have the geometry, discretize everything, subtract the obstacles, define where you start, where you end, and then it will automatically search the path. And this whole process, like bringing in the geometry, discretizing, this is also automated. So you just define what you are doing, these steps, and then you can just change the geometry at the start and the points that you want. Maybe you have an Excel sheet or a point table, or maybe you have a data sheet for plugs where you know where the points are supposed to be. And these will be automatically selected while you import everything. And then it runs through and then gives you the path as an output.
Yeah, that makes a lot of sense. And I think even in the video, you kind of explained that you don't even have to jump back to CATIA, for example, or any other CAD program. So you could just see the updated version of the cable routing solution, basically, in real time in the program without even opening it. So basically, you see it in real time. Is that correct? How does that work?
Yeah, so you mean you don't have to leave CATIA, or you mean you don't have to leave
Synera?
Okay.
Yeah.
I mean both is possible. So what we can do is we can run Synera in the background. It doesn't actually matter because you define the process, and what you do with it is your choice. In the end, it's all about do I get the geometry that I want? So this is something that I always have to define with customers, which is do you want to actually have the 3D geometry of the cable, or do you just want to have this line? Because sometimes they have internal tools where they select the line and then it automatically creates a cable. Because this process of creating the geometry can also be a bit tricky depending on the CAD system you use. So that's why. And I don't see a problem. So what happens is you either export the geometry that you have and bring it back into the CAD system, CATIA, or you somehow connect it with our tools that we have directly connected with CATIA, and then it's real time where it updates the geometry.
Yeah. The workflow, or like the cable routing algorithm that you've described, is it only applicable to power electronics, or do you have any other applications in mind where this is like very beneficial for the engineer and save a lot of time?
No, I mean, we have already prospects where we use it for piping, and we also have prospects where it's about, I don't know the specifics of it, but they actually use it to find the optimal position of certain geometries. It's not always about cable path routing or piping. It can also be something where you want to find certain distances or positions of geometries in relation to each other, basically. Because we can do parameter optimization inside this solution space that you have, and you can move automatically the parts around and then try to find optimal positions for the parts in relation to each other. And this way you can also use pathfinding. I mean, search algorithms in general, you have to think about what can I do with this information. The information that you get is always point A to point B in a certain, I would say, criteria. In terms of A star, it's always the shortest path, but you can also use other algorithms if you want to program them yourself and then have different criteria, which I actually did in my thesis, for example. I modified the A star algorithm to have different criteria and get different paths.
Yeah, very interesting. What would you recommend people to do? Let's say they listen to the podcast and say, maybe I have the same problem, maybe something maybe a similar problem. How can they actually get started? Is there already like predefined workflows that people can try? Like, how does it work?
Yeah, and our software is actually quite simple. We have all the steps outlined. In terms of the algorithm itself, I mean, it's already written. You just use a node, then plug in the inputs, the start point, the end point, and the geometry where you can search or where you have the search space, and it will automatically give you the output. And in terms of what you do before that or after that, it's really up to you. But we have an extensive amount of learn material where you just click the example files, for example, which a lot of users use. It usually shows you finished examples on how to use it. What users normally do is they copy paste it and then just replace the inputs and then see what happens. After that, usually the next step for the user is that they contact us and ask us about more in-depth questions, I would say. So they ask us, can I also do this? And how do I connect it with parameter optimization? This might be a bit more, take a bit more time, but it's also not that complex. So we're always happy to help. And these are the first steps, I would say, that the user normally does.
I think it's well summarized. And then we'll also link like to a 14-day field trial down in the description so people can check it out. Because you have so an extensive experience, Rahman, with working with customers and prospects, what would be like some of the misconceptions people have before using Synera, and maybe once they started like to understand what process automation is all about? Like, what do you see like a mindset shift maybe from the engineers? Like,
yeah,
so like a top three.
Yeah, sure. So my opinion, the first thing they misunderstand is always it's an extra tool that I have for helping me achieve some goal. So some people think it's a CAD tool that tries to combine it with simulation, FE simulations, and then they have this mentality of, okay, this is only for this part. So I want to, maybe a lot of people, they directly think, I want to automatically simulate something, and that's it. I don't want to do anything more. There's no, for example, parameter optimization to try to find different designs and different variants and check out the different results that you get while automatically simulating all the different variants. So this mentality usually is not immediately there after the first introduction to Synera. I would say after the user gets a bit into the software, they understand, and also after we explain to them what other possibilities there are that they can do. The next thing I would say is that they always stay in their own field. So users usually either stay in CAD field, or when they are simulating, they stay in simulation and don't want to touch the other things. But I would say there needs to be a real change where engineers should have the confidence where they can say, okay, I'm not a professional in simulation, FE simulations, but I understand the basics of it to the degree where I can set up stuff and where I can understand what my colleague who is doing it professionally actually does it, And in this way, you will become an all-rounder, I would say. I mean, sometimes all-rounder can be a negative term. Or some people think it's you can do everything, but you are not a pro at anything. I would say we need to actually change this mentality of you cannot do simulation, or you don't understand this subject because you didn't study it, or you didn't do it for 4 or 5 years or something. Because in terms of general application, you can actually learn it quite fast, in my opinion. And everything else is usually a matter of talking about it. When you do a simulation and your colleague comes and evaluates it, you can talk about it, what you need to change and what you need to do to make it better. But in terms of setting it up inside Synera, I would say we have all the tools possible where you can actually do it, and you should not be afraid to dive into subjects where you thought, this is not for me.
Yeah, I think it's exactly what you talked about, is kind of this connected engineering approach, right? Kind of bridging the gap between like the steps in the product development process. What has been some of the coolest project that you've been working on in the past? Obviously, if you can talk about it like live in this podcast.
Yeah, I would say I didn't directly work on it, but I would say the machine learning stuff is really interesting that we have in our portfolio. I cannot talk about the things that our customers are doing, but we did this cool project with our colleague who developed most of the AI stuff, where they predict the optimization shape of a geometry based on the loads that you apply. So you train the model, and then you just tell where the forces are and how it's fixed, and then it will tell you the optimized shape. And this can actually save a lot of time for anyone who does optimizations. They know that it can take hours or days until you get a shape, and the result might not be good after that. So that's a bummer always. And if you can get just it doesn't even need to be perfect. If you can get different variants from prediction, where you see the optimal shape, and then can maybe think, okay, as an engineer, you can look at it and see this might work, this might not work. This can actually save a lot of time and maybe even be something that you can directly use. And I think this is one of the coolest projects that we have done until now. In my opinion, what I've done in this last year actually was my thesis. I think it was pretty cool because I learned a lot of programming and also the algorithm stuff. Like I said, I didn't study computer science, so actually I had to teach myself. But it actually works out quite well. So you start to understand the, I would say, intricacies of the software, and also see the possibilities, because in Synera you can also just program your own whatever you want, right? So you can use all the possibilities that we offer and then develop your own node and then have your cool algorithms do whatever you want.
How did you personally perceive it? Because you mentioned that you had to teach yourself programming, right? And then you went into something which is kind of a low code environment. How did you perceive that, like from when getting started with it?
Yeah, I was thinking, first of all, I would recommend always, this is something I realized after a few months, I would say, you should separate like what you actually want to achieve and what you want to do inside Synera and what you want to do inside the code, because sometimes you directly start writing the code and then you want to do everything. But you realize we already have functionalities which you can use to do most of the job, so you don't need that actually. So really focused, writing only what you want, what you need, and then apply it. And I think, in my opinion, it was pretty cool to realize after I developed my first node that we can actually do everything. So in my opinion, so in terms of geometric manipulations, CAD, FE simulations, of course, there are the limitations depend on the software that you try to connect, but still you have a wide variety of the things that you can do. And this is something, a realization for me was that we can actually do a lot of stuff.
Very, very insightful. And I think to wrap up the podcast, Rahman, always the last word goes to the guests. So maybe some motivating last words to the engineering community and people maybe who are a little bit hesitant to use Synera, but they want to maybe delve into it. Maybe they contemplate like maybe using Synera. What would you tell them?
Yeah, I would say the biggest hurdle always is this, like I said before, the attitude of I didn't study a certain subject, but this program offers something for all the subjects, and then you think, okay, I need to actually know this, and then I need to know that. And I don't want to go into this because it takes too much time, in my opinion. That's a that's a mindset that's not really working out, because at some point you have to ask yourself what you are doing in your job, and do you want to learn the other subject fields that your colleagues are working on? And I think having this open mind to actually dive into it and try to understand it is the crucial part, where you become a Synera user and you start to realize, okay, I can actually do this, and I can actually understand what my colleagues are doing. And we also offer these example files, explanations on how to build this stuff. So it comes to a point where you have to realize you can do the basic stuff, and later on you can talk about it with your colleagues. And this is where you connect, basically, this connected engineering mentality, where everyone knows not everything on a high level, but to the point where everyone understands what the other one is doing, and how you can automate the things that you want, so that you can work together more efficiently, I would
Yeah.
say.
Yeah, that makes a lot of sense. I think great way to end the podcast, Rahman. Thank you so much for the insights into cable routing algorithms. And again, I link every relevant link to workflows, maybe pages, also the LinkedIn profile to Rahman if you want to connect with him, down in the description, so you can also get in touch with him if you have any problems or maybe questions to Rahman. With that, thank you so much, and I hope to see you soon in a second episode.
Yeah, thanks, Yusuf. Thanks you very much. See you.